Okay, this is going to be our first formal lab, so I figure it'd be a good time to go over the lab grading rubric that I'm going to use to evaluate your performance in the lab. So there's a few components that aren't listed in the general rubric that I want to mention. This year we've decided that we're going to collect a hard copy of your data and observations prior to leaving. You guys need to take a picture of that so you have that to do the work, but it's our way of ensuring that you A, did the lab, and B, were contributing and at least paying attention while you were doing it. So that'll be worth 3 points. The other thing is that you need to clean up your messes. So your lab bench will be cleaned afterwards unless I permit you to leave something, say an experiment's still running. So those will be worth a total of 5 points, so 3 and 2 awarded to that. Now into the important part of the lab. So the first thing you're going to write in the lab report, besides the heading, which includes your name, the title, the class, and the date, is basically a description of what's going to happen in the lab. So in most of the labs that we do during the year, you're trying to solve a problem or figure something out. So the introduction, basically, you're going to describe how you're going to solve the problem. Not necessarily the physical stepwise procedure that you're going to do, but strategically how you're going to solve the problem. For example, in the activity we did yesterday, where you guys were determining the thickness of aluminum foil, you first had to find the density. How did you do that? You used water displacement of an aluminum cylinder, you found the mass, you used that to find the density, and then you use that density to then calculate the volume of the aluminum squares, and then from that and the area you were able to calculate the thickness of the aluminum foil. So what I would want you to do in that lab, for example, is to basically connect those dots and explain how you're going to solve the problem. All right? The concepts will be linked in a problem-solving strategy in a detailed manner, and when we get further in the year we're doing chemistry, all applicable chemical and mathematical equations are included, related, and explained. So this is actually going to be a large portion of this grade. So if you do a really good job on it, you get 7 points. If you do a pretty good job on it, you probably get around 5. If you leave some important stuff out, you're going to get a little bit of a lower score. Then, once you do that, you describe what you're going to do conceptually, then you describe what you do physically. So the next portion is the procedure, safety, diagram, and materials. In this, you're going to provide a procedure that's clearly stated in a detailed, articulate manner, and major safety concerns are expressed and precautions are identified. Your diagram and materials list should contain all items you're using and show an appropriate lab setup. Remember, when you're writing a procedure, you need to be technical with it, like saying, using a scupula, transfer blank grams of whatever into some whatever. But you have to be specific with how you're going to do it. Try and be technical. The third portion that you're going to look at is that I'm going to evaluate is the data table, graphs, and calculations. So the primary data table includes only things that you directly measure in the lab, not any calculated values. So any calculated values that you want to show graphically or in a table, you need to put in a secondary data table. All right. Your calculations and your measurements should all have the appropriate number of digits. Okay, so use the appropriate number of sig figs in your measurements as well as the calculations that you do with them. Graphs should be organized, X, Y axis. Make sure they're labeled appropriately. If you're trying to point out information on it or include a trend line, make sure you do so in that. Then, once you've completed that portion, once you've performed your calculations and made any graphs, what you want to do is provide a discussion. So the discussion relates the results to the objectives, describing the problem-solving strategy, and saying what you got along the way. You also want to identify any possible sources of error or uncertainty and describe their impact on your results or calculations. So like, for example, if you had a chunk of the aluminum foil missing in your measurement, then the true area of that foil piece was not what you reported. You need to say whether that's going to make your calculated thickness higher or lower, and that's for you to think about. The conclusion is just a concise statement. The objective of the lab was this. This is what we found. Report an appropriate way to quantify that, whether it's like a % error or a % yield, and make any suggestions for improvements in the future.